All right, this is a lesson on Charles' law. The good thing about gas laws is that if you know the formula, they're just like any other one. So after you learn how to do Boyle's law, the other ones are really easy. You just have to know the formulas. Here's the difference. Charles' law relates volume and Kelvin temperature. It's got to be in Kelvin. It can't be in degrees Celsius. It can't be in degrees Fahrenheit. So here's what it has. It says that volume and Kelvin temperature are directly proportional. What does directly proportional mean?
It's not opposite.
Yeah, they're not opposite. That means if one of them goes up, the other one goes up. If one of them goes down, the other one goes down. So like, for example, here's what I say. If pressure's constant, temperature increases, the volume will also increase. And I didn't explain why. You should already know this. Remember, if you have if you increase the temperature, it makes the molecules move faster, right? And so if they're moving faster, then they're going to spread further and further apart, and that makes things expand. You know that when things get hot, they expand, right? When things get cold, they contract, correct? Except ice, and that's a whole different story. So that's what happens here. And so you would expect if you increase the temperature, the volume should get bigger. If you decrease the temperature, the volume should get smaller. We have an equation for that too. Here's the equation. V1 divided by T1 equals V2 divided by T2. Now, here's the problem with this. Well, I don't really know if it's a problem or not, but it's got to be in Kelvin temperature. So notice that if I give you a temperature in degrees Celsius, you have to change it to Kelvin. If I give it to you in Kelvin, leave it. But if I give it to you in Celsius, change it to Kelvin. And let's face it, most thermometers are going to be measuring in Fahrenheit or Celsius. They're not going to measure in Kelvin. So almost every one of them you're going to have to change. So when you change this, here's what you do. You take whatever your Celsius is and add 273 degrees. Let me say that again. That's important. As a matter of fact, let me write it right here. If you're going to find Kelvin, you're going to take your degrees Celsius plus 273 degrees.
So 273 degrees, 0 Celsius?
Yes, it is.
Okay.
And the question was, what if you have Fahrenheit?
Yeah,
I'm not going to give you one in Fahrenheit. There is a formula to do that, but we don't use Fahrenheit as a scientific temperature scale. We measure everything in Celsius. Therefore, you don't have to worry about changing from Fahrenheit to Celsius. All the things I give you will either already be in Kelvin or they'll be in Celsius. What if I ask a question that says, okay, I want the answer back in Celsius? I will just subtract 273. So if I want degrees Celsius, I take whatever I have in Kelvin and subtract 273. Learn these. They're not really gas formulas, but that's an easy thing that you have to do that a lot of people will forget to do is make sure your temperatures. It's got to be in Kelvin temperature. All right? If we go... Okay, now I'm going to do this problem. Okay? So let's label it first. Those of you who are having trouble with algebra when we're doing Boyle's law, label it first. That'll help you out. Okay? If you're having trouble setting them up, label them first. So here, a sample of neon gas occupies a volume is 752 at 25. If that's volume 1, that's temperature 1. If I had labeled that as volume 2, I would label the other one as temperature 2. What volume, in other words, this is what I don't know. Volume 2, I don't know. Will the gas occupy at 50 degrees Celsius? The volume I don't know, I want to be at 50 degrees Celsius. So therefore, that's my volume 2. Now keep in mind, I'm going to get ready to plug my numbers in. Since I have 2 volumes and 2 temperatures, I'm using Charles' law. So my formula is V1 over T1 equals V2 over T2. All right? My volume 1 was 752. All right? My temperature 1 is 25 degrees Celsius. My volume 2, I don't know. My temperature 2 is 50 degrees Celsius. Now, before I go any further, can I use these temperatures? I've got to add 273. So I'm not going to use 25 degrees Celsius, Dylan. I'm not going to use this right here. I'm not going to use 50 degrees Celsius right here. What I'm going to do is I'm going to change those to Kelvin. So 25 plus 273 is 298. So instead of using this right here, I'm going to change that to 298 Kelvin. All right? And 50 degrees plus 273 is 323. So instead of using 50 degrees Celsius, I'm going to use 323 Kelvin. By the way, notice that Kelvin does not have a degree mark. I don't know why. It's just the way they just call them Kelvins without a degree. So now I'm going to extend this page a little bit. So you can see, I'm going to rewrite that so you can see it clearly. That means 752 milliliters divided by 298 Kelvin equals volume 2, which is what I don't know, and 323 Kelvin. If I'm solving for V2 in algebra, what am I going to do with this 323? I'm going to multiply both sides of that, right? Correct? So I'm going to say 752 milliliters times 323 K equals, divided by 298K. It would have canceled out on the side, and that equals my V2. All I have to do now is do my math. So, mathematically, folks, understand I'm going to say 752 times 323. Everybody agree with that? And then I'm going to take that answer and divide by 298. Let's see what that comes out to be. 752, I messed up. 752 times 323 divided by 298. And I get 81.6 milliliters equals V2. Look, my K cancels out. That's why milliliters is my unit. Okay? Sorry, this is wrong. Let me erase this. I say erase it. Why can't I erase this? Oh, yeah, that's what it is. There's a pen missing. Okay. Sorry. Redo that math. It comes out to be 815 milliliters. All right. Somebody check. Okay. So we have here temperature 1, volume 1. To what temperature? That'll be temperature 2. Must occupy volume 2. All right. Notice that your temperature 1s are together, your temperature 2s are together. So what I'm going to do, I know that this is volume 1 over temperature 1 equals volume 2 over temperature 2. Just plug in the numbers. Here I have for volume 1, 375 milliliters. Here I have my temperature 1 is 0 degrees Celsius. I can't use 0 degrees Celsius. I'm going to add 273 to that, and that becomes 273 Kelvin. All right? Does everybody understand that? Why I'm not using 0 degrees Celsius?
What is 273?
When you go from Celsius to Kelvin, you add 273. So since it was 0 degrees Celsius plus 273 gives me 273 Kelvin.
All right.
Equals, volume 2 is 500 milliliters. Temperature 2, I do not know. Since your variable that you do not know is on bottom, you need to cross multiply. So what I'm going to do is I'm going to say 375 times T2 equals 273 times 500. Okay, if you solve for T2, you get, was it 364? 364 Kelvin. Hey, but look, when I look at the problem, it says to what temperature in degrees Celsius. So I had to do it in Kelvin, but I'm not finished. What I'm going to do now is I'm going to say 364 minus 273 equals 91 degrees Celsius. That's my answer.